Okay, welcome to Nested Loops. We're doing chapter 7. This is, of course, POODR. Welcome. Scott's going to turn it over. I'm going to turn over to Scott, and he's got some slides to share. So, and of course, feel free to ask questions during. You don't have to wait till the end. So with that, Scott, why don't you present? And I'll mute mine.
Hello, everybody. Okay, I'm Scott Smith. I work with Forrest here at Hedge High in beautiful downtown Dana Point, and we have been covering the POODR book. I'm excited to present on Chapter 7 with roles because they're complex, and I've been playing with functional programming, and they have a kind of a different way of tackling these kinds of issues, and I can see in Sandy's recommendations that there's some commonality there. I'm not going to go into the functional part of it, but it is a challenging read. Okay, so in understanding roles, basically going to go through the book that's the chapter that Sandy wrote very, very well. Kind of skim over some of the details, which you should have all read about anyways. What I hope for this to be is a higher level investigation, and if you are having questions or clarifications and you want to make a contribution, just please jump in. This can be as much a discussion as anything else. So what we're going to do is we're going to cover finding the roles, and roles have responsibilities. They get very complex very fast. It is extremely easy, and I think we've all been in code where these concepts were not understood and implemented very well. So you've got to be very careful on how you put this stuff together. Unnecessary dependencies are a killer. So we're going to build on what we've seen in previous chapters on the duck type for, in our application, something called schedulable. We're going to talk about how objects, if they can speak for themselves, it not only is somewhat easier to write, it's easier to maintain. We're going to consider writing the concrete code, identifying and extracting the abstractions. I'm not going to be real code heavy here, but I will be on the sequence diagrams and class diagrams. Going to proceed on the complexities of when you abstract the code, there are various ways to do it, and they get exponentially more challenging as you go through, so there are some recommendations on that. Finally, we're going to talk about inheritable code. And inheritance is not only classical inheritance, but it's also what Ruby implements as modules, other languages implement as interfaces. So we'll go through these, and let's get started. Okay, so the first thing I want to talk about is finding roles. And in this chapter, the roles that Sandy has identified for her bicycle application are preparer and preparable. So we're going to use those as examples. Yes.
Can you enter presentation mode?
You know, if I jump to presentation mode, I don't know how it's being shared. I can try it. It's driving me crazy. I don't know how to do it. Let me try a quick one and tell me if this looks better.
You hit play.
Now, are you still seeing the same thing?
Yeah.
Yeah, we're seeing the same thing.
Okay, so you are seeing finding roles.
Well, they see the.
Yeah, but we see.
Oh, I see. You see the old one.
The navbar and thumbnail. Oh, and don't worry about it, man.
Okay, it's a technical difficulty, and I apologize. This is the brand new keynote from Apple, and I've loved assembling this this presentation.
Google
What's that?
Well, I suppose if you share the whole screen on the smaller one, and share that with Google Hangout, that would work.
Or maybe what I do is I disconnect the big monitor.
Yeah, you could do that too.
Let's try that. Okay, let's see if this works. Can you still see this?
Yeah.
Still the old one, but okay.
Yeah, I don't know if you share that screen.
Oh, that did not work out well. I just disconnected my mouse instead of the monitor. Okay. All right, let's see. Well, the lesson is never try to change your technical configuration in the middle of a presentation. All right, back to where we were. All right, are we where we were now?
Yeah.
Okay.
Yeah, you're good. Slide only. I didn't even show anything on. Okay, so I gained a bit. Okay, so so the chart I have below is something I'm going to hit at the end, and that is roles in large systems become very complex, and everything that they relate into is this word I learned about for the first time when I prepared this called ontology, when I was just trying to get some other material for this whole topic of roles. And there are some unbelievably sophisticated tools for just managing these kinds of things, and it's a vocabulary, and I'm sure you could spend an entire graduate school experience learning about ontology and the tools that apply to it. So I'm playing with a very, very small piece of what is ultimately a very sophisticated topic in computer science and business organization. So let's hope the arrow keys here work. Again, recommended, never change your, got to use the navigator. Okay. Role requirements are, you have, in single inheritance, an object basically has a single role. And what we've done is, what many languages have done is they've implemented new concepts such as Java's interfaces or Ruby's modules to assign actually kind of multiple inheritance hierarchies. Ruby's notion of modules has been generally adopted by several languages and is found to be manageable and useful. So I call something concrete classes. These are classes that are the ultimate representation of an instance. And concrete classes automatically, in Ruby, they automatically delegate as necessary not only to superclasses, but also to modules, although it gets complicated. Okay, so an object can be programmed to respond to messages. And if an object has different roles, well, it may have a primary role through itself and its inheritance. But if it's got multiple roles, it's going to probably include modules. And it turns out that superclasses can also include the modules, and this becomes tricky because your roles start to blend. So if you're afraid that a rat's nest of code could evolve here, that's absolutely possible. And you got to watch out for it. That's what this book talks a lot, this chapter talks a lot about. Okay, so here's an exercise in organizing responsibilities for roles. And in Sandy's book, she has a schedule module. And her targets, various forms of entities that are needed in a bicycle business, such as bicycle, mechanic, and vehicle. She wants them to be scheduled. And so the target contains an instance of bicycle, vehicle, or mechanic. And we have this module out there. And so the target, if it's asked, is it schedulable? Well, it can itself go to the schedule module and ask it questions, which will come back and tell it, okay, I'm schedulable or I'm not. The violation of principle here is that the schedule is really not an innate part of what these targets are. These targets are bicycles, mechanics, and vehicles, and what they need is they need to respond to schedule requirements, but they in and of themselves are not schedules. So this is the first attempt to move that stuff out. So, oh geez, this is repeated. Okay, so I've already covered this. What happened to me? This is why I need to know how to use this tool before I actually run it. Okay, so the instigating object instead can ask a schedule itself, in the schedule, if it has the target, it can go back to the target and get something that's more a property of the target, in this case lead days, and then the instigating object, the schedule then has enough time to respond with whether the target is schedulable or not. So in the previous slide, the instigator is asking schedule, is a target available? Why not ask the target instead? So, all we have to do is we can add schedulable as something that the bicycle knows how to do. And so when the target is asked, if it's available, then the target itself can go off to schedule and ask schedule to calculate whether it's schedulable or not, and then it can return the result. The problem with it is the concrete target is still violating SRP, and that is it still knows too much about scheduling. And so if we want to implement this in others, then we're going to have to implement a lot of code that the target right now needs to know. And so we're going to copy pasta these details into each of the targets. So Sandy suggests that maybe what you can do is you can create the module schedulable to just take over the management of the method schedulable and scheduled question mark altogether. And what makes that really nice is that now for each target, such as bicycle, all you have to do is include schedulable, and schedulable can get back to the target to get the lead days. And if the target doesn't have lead days, and it says, well, it doesn't have any, then it's an impressive reduction of scheduling in the target. All the target has to know is schedulable. And the nice thing is that in Ruby and other advanced languages, Bicycle will automatically delegate to Schedulable all the things that Schedulable does without having to implement them in Bicycle, and hence you can save a lot of the copy pasta code. So the instigating object now can say, hey, Schedulable, is this schedulable? And the schedulable can then go off to schedule with the calculation of the lead days, get the answer, and it can go back. So this was kind of a reminder for me just as to how automatic the delegation can be. What's interesting to me is how the target, whether it's a bicycle or a mechanic or a vehicle, drops out of this view. Okay, so what we're to determine whether something is classically inherited and goes up to a superclass or goes out to some kind of templating like modules, the central concept seems to be is a or behaves like a. And a bicycle is inherently a bicycle. It may have behavior that it needs to respond to for Schedulable, but that's templating. It's not what a bicycle or a vehicle or a mechanic is. So in order to see the implications of this, Sandy goes through a sequence of exponential complexity growing in this particular part of the chapter, where she talks about how each of these inheritance mechanisms actually fall out when you are attempting to select which ones to use. So she goes through a gross simplification, and then something that's more accurate, and then something that's finally very nearly complete. We'll go through each of these at the same, one at a time. Okay, the gross simplification is the systems have only traditional classical inheritance. So you have an instance of a mountain bike at the bottom, which belongs to a class, mountain bike, which inherits from a superclass bicycle, and then the ultimate superclass object. In order to find out what's going on, to figure out how to make a change to the code, in this simplification, all you have to do is traverse the superclass sequence. Not too hard. But this is not flexible enough to handle roles. Hence, she says, somewhere along here, you're going to start overlaying modules. And so in this particular case, she says, okay, a bicycle is schedulable. So in each bicycle, I'm going to put a schedulable module so it can use it. And then it can also do this for vehicles and mechanics. Notice, however, the cost of this is that it's getting somewhat more complex. You've got more things to traverse. And when you dig down into the details, you know, it may get as complex as this. You have an instance of a mountain bike that's actually done as an instance only, a singleton class, which has modules, but also inherits from a mountain bike, but which also has its own different set of modules. But overall, mountain bike still inherits from bicycle, which in turn has its set of modules, and then at the top of the tree is object. And at this particular point, you can see that things can get really complex to find out what's going on. So at this particular point, she says, this is what you've got to deal with. So now what we're going to do is we're going to discuss some concepts about writing inheritable code. If you don't get this right, then you get very frustrated with how lost you can get in implementing a complex system using classical inheritance and modules. And I am guilty of this. You know, I have some pretty crappy code out there because I didn't understand these things. Okay, so there's some obvious anti-patterns that scream, don't do this, and when you see it, it almost deserves to be instantly ripped out. But if you're going to avoid the anti-patterns, then what are you going to do right? And what she says is we're going to make sure that we abstract right. And in order to abstract correctly, we have to understand what a contract is and how to honor it, and how a computer science concept called Liskov substitution principle will help you understand that. Why the template method pattern is so key to keep this stuff more simplified than it can otherwise be. Techniques for decoupling classes and how and why shallow hierarchies become very preferable to keep things from getting overly complex. Here we go. The anti-patterns. If you see if-then logic to determine whether the you're asking about a type or category of object within your object, you're already in trouble. So if yeah, you're in trouble. So if you are the receiver and you've got this kind of logic, someone's asking you a question about, and you've got to ask yourself, what type or category am I? Instead, just put this in an abstract superclass, the common code for the provide methods that cover the abstract. Golly sakes, I need to back out here for a second. If you're a receiver and your method has to figure out, okay, what am I? Then put an abstract class up there, insert it above you, and have the methods that are unique for each of the types, and then only implement the types in your particular subclass and invent other subclasses underneath that abstract subclass to do things that are special to other types or categories. That's if you're receiving the message. If you are sending the message and you have if-then logic to determine what you're looking for, then instead identify a duck type or common method, and then all the targets, if they implement the same method, then you've solved the problem. And if that method implies the same behavior, then that behavior can be implemented in a module, and all you have to do is call that method in the module, and the module will implement that shared functionality. So there are implied contracts here that if you don't follow, your code becomes a mess. If you insert an abstract class, then the code that's in that abstract class must apply to all of its subclasses. And superclasses should not contain code that only applies to a subset of the subclasses. This takes discipline. And one clue on that is if you have a subclass that has a method saying, oh, I don't implement this superclass method, that's a red flag. That's code smell. So be reluctant to violate those principles. If you're unable to do so, then look seriously at maybe inheritance is not the correct solution here, or it needs to comprise a smaller part of what you're trying to do. So she has a math expression for the Liskov substitution principle. What I really want to refer to is the implication is a subclass can be used anywhere its superclass would do. And objects that include modules can be trusted to interchangeably implement the modules role. So if you want to schedule a bicycle, and the schedulability is in a module, and the bicycle has a module, that module, and a vehicle has that module, then a vehicle can also be scheduled. We had some discussion of this in one of the previous sessions we had. That's the template method pattern. And there was this controversy about when to use that versus just normal inheritance. And one thing about putting together a presentation is I was forced to look at that more carefully. What she's pointing out is modules are just another inheritance strategy along with duck typing. So they are all it is a way of spreading out your inheritance so you don't have everything in one classical inheritance sequence. Template methods represent the parts of the algorithm that vary, and it's recommended that she recommends you use them because when you use them, it forces you to make explicit design decisions up front about what varies and what doesn't. So it becomes more declarative. So the problem is that implementing super and initialize needlessly special cases your code to classical inheritance. And if you're going to undo it, you're going to have to move more things around. Hook methods are a workaround for classical inheritance that is one of the template methods solutions. And they work great, but you may need super in the overriding method if you have more than one level of inheritance. So here I show mountain bike derived a subclass from bicycle and monster mountain bike subclass from mountain bike. Both implementing local spares. It won't, if you invoke this on monster mountain bike, an instance of that, unless you have super on the method, it's not ever going to see the local spares that are also needed by your superclass. So here's a place where you still need super, but it's not super everything. Finally, in this chapter, she says, create shallow hierarchies. And what it all basically boils down to is that if you have deep hierarchies, then you have extensive networks of dependencies. And the bottom line is those extensive dependencies, each of which might someday change, means that you've got a lot to run down if anything happens, particularly in your middle dependencies. So here's what I got from the summary. Modules are an extremely flexible implementation in Ruby. They can not only be added to a class, they can be added to a superclass of that class or another module used by that class, or even to an instance. Because modules can be almost anywhere in your object hierarchy, they and they interleave, they use an inheritance. They all mirror inheritance on doing this. So you want to keep those unintended interactions minimized by using the template method pattern and hook methods to avoid forcing super as much as you can. And then finally, an object is committed to honoring all the contracts of all the superclasses and modules it is using. And it should also use appropriate modules to simplify the to use contracts when it's looking for an object to receive a method. It should use modules and duck typing in order to not copy paste the rules for what those are. And we're at the end, so we have a long time for discussion and questions. Before we do so, I would like to show a little bit of a bonus, and that is the ontology that I was talking about. I found I did a little research in ontology, and there's a very sophisticated program called Protege, and there's a link to it, and there's quite a bit of discussion about a whole vocabulary I'm not familiar with that descends into just how meticulous and precise it can be when you're getting into large systems. Because as you can imagine, the mistakes you make that drive us crazy enough in our lesser Ruby on Rails systems become catastrophic in more complex systems, and they have to have rules to manage them much more carefully. So I just put that out there.
Hey,
That's it.
Comments or questions?
That's good.
Anyone?
Oh, no. Okay, well, I have stuff.
Oh, I'm going to let you take over, and I'll turn off mine.
Sure. Okay, so if I were to go back and summarize this, we'll talk about, I think, the purpose versus the implementation. So we talk about the title. It's sharing role and behavior with modules, right? And then as you go in, you find out what she means by roles. So that one chart that Scott had with inheritance is versus what he put as template. I don't remember if that's the language that Sandy used. Behaves like. So I don't know if any of you guys are Java guys, if you remember Aspect J, aspect-oriented things. You know, the big buzzwords with that were cross-cutting concerns, and one of the big examples is logging. Logging is something a lot of stuff does, but it's not the essential part of that object. So the whole aspect J, well, geez, because we're Java and we have single inheritance, you know, and how do we get this cross-cutting concern without, you know, cut and pasting code across, because we can't inherit from a second object. Of course, you can delegate or you can implement an interface, but both of those become kind of suboptimal. And in this case, if it's code that's common across everything, which her example makes it, then it would be really great if you could, quote unquote, inherit from some other thing in a system that's only single inheritance, which all along this time, the C++ guys are just laughing at us. Oh, no big deal, just inherit from another class, which has its own issues, but which I kind of want to come back to. You have to be careful. But if you look at Sandy's story here, well, you got to be careful. You have to be careful here too. So we multiple inherit via including modules, but now we have to become careful. And offhand, I don't remember the mechanism aspect J on how you like what. Okay, Scott was talking about, like, at the end, the roles you have to implement. Don't do the not implemented here thing. So tools that Java gives you is, well, you can declare an abstract class and force your children to declare to re-implement the abstract methods. Or, you know, you can also do the interface. So Java gives you some type checking of whether you've done some of that stuff. But of course, they don't give you the multiple inheritance part that we're looking for here. And if we jump to C++, if you do multiple inheritance, it's the same concerns. You got to be careful that if I'm doing multiple inheritance, that I don't put stuff in super that conflicts with other super. So I don't think there's any answer that keeps you from being careful. And I realized I had one more chart to the Sandy's final chart with the 3 modules. You could actually monkey patch object to include modules and have a 4th set of modules for you to look for. So it can be very hairy if you're not careful, which goes back to thinking about, well, think about, and she calls out a template pattern, think about how you design things. When you're doing template, you have an idea. This is the template for everybody. This is the algorithm, the things you will do. And you give opportunities for subclasses to re-implement or override the implementation for certain parts or all of parts of that template. That requires you to figure out what's common and what's changeable. And then with a little indirection, you can add that one thing. But I think no answer lets you not be careful. Right? With Java, you can do aspect with aspect chain. I haven't really followed where that went, but that was one way because it really bothered people that they would have to cut and paste or implement or even delegating to another object. You'd have to go and instantiate boom. And so if suddenly you wanted to go and add logging to 20 classes, you have to go in and fairly intrusively add that thing, right? Ruby gives you modules which bypasses the super initializer because you don't have that part in the modules, but you still have to be careful. You still have to pay attention to some people, your methods maybe in the module might count on something in your constructor. You have to be aware and you have to figure that one, and maybe you can address that through hooks, which again, don't solve all the issues, and you still have to become aware. So it's no free lunch here. The big bonus with modules is you can not cut and paste and not force a delegation and with one line inherit new functionality. If you design it right, if you have the right template method, break part, it works for you. But there's still, you got to be careful. So, all right, there's my summary. I don't know, was it a diatribe? I don't think it was a diatribe, but that's my summary thing over that one. Yeah, but no magic. But somewhere the C++ guy laughing at you. Oh, why is that so hard? Just inherit another class and be careful with your constructors. So, and then, Bjorn Sostrup is saying, yeah, I invented that shit 40 years ago. So, there you go. So, comments, questions? Andrew knew all this stuff because he had no questions.
Well, the way I see module is like we're getting new methods or new constants, but like, or maybe not new constants, but it's different from when we have a class because we're not declaring an object. Yeah, we're not saying we want a new object and have this method and a response to these methods. We just have methods that we can pass on to whatever object to respond to this.
Right. So Diego must have an opinion, no? Diego should be next to Andrew. Oh.
Hmm?
Diego has
Did I talk? I didn't think about this headphones.
No opinion. Matthew, were you able to follow along?
Yeah, I mean, I was able to follow along. I didn't understand everything, to be honest. I'm new to Ruby on Rails programming, and I haven't actually read any of the book yet. So if you can forgive me for that, but I'm happy to follow along and pick up what I can pick up.
Yeah. So not surprising, we're in chapter 7 of the book. I don't remember if it's chapter 6 or chapter 5 that she introduces template methods. So obviously it builds upon the previous stuff, but ultimately we're really trying to figure out what the book I would say is trying to figure out is how to give you, I want to say, the most maintainable code or more maintainable code via various object-oriented techniques, principles, things like that, right? So if we look at this part here, and so the code here, her running example thus far has been this bicycle shop. And so the code all fits. It's one of those things, if you've seen this earlier chapters, it fits together a little better. Oh, she's piecing together, you know, we get, and the reality is you get requirements over time. So part of what makes your code more maintainable is, well, God, how do we duct tape this thing on that we had no idea was going to happen? Well, preferably it's not so duct tape, you know, and techniques for that for this one. So at this point, with the previous chapter, we're starting to see, oh, a bunch of these things, the mechanic, I forget what the other guys were, this thing. These guys all are things that are, in 2020 hindsight, are schedulable. So this is kind of a role. So then we got the scheduler and the things that get scheduled. So at this point, we come into, okay, well, now that we have these, again, this concept of, this is a big design pattern principle, figure out what stays the same, which is what changes. That's really what template pattern is. The template in the current class is what doesn't change. We all do these 3 steps, but each one of the children could redefine one to all of those 3 steps in a subclass. Right? So we get here, okay, we got this code, and we don't want to cut and paste. That's what we do. Magic is Ruby, we can put all that code in a module and include it, but there are some caveats on what you should and should not do. And most of these, what you should and should not do, ultimately for code that is minimum of duplicated code and easy to understand, easy to change. Yeah, right? That's kind of your the ongoing happiness as a coder. Those things matter to you. So there you go. And I see we have another guy joined almost at the tail end, Leandro. So he caught what, the summer, I think. So but you can go back and watch YouTube. So questions, comments? Everyone knows everything.
I love Ruby modules.
Okay, well,
Yeah,
if we got
it's a good thing they're there.
Yes, if we got no discussion, we can wrap early. Let me figure who's going next week. So we have been rotating among the people in the group. We can make cool slides, which they got who pushed us in this direction. Was it someone? Was Andrew the first guy to put slides up? I don't think it's necessarily required. You can talk, you can share the screen. We kind of rotate. It's nice. It's nice for us to, for someone else, for a change, different perspectives. Feel free to chime. So if discussion's done, we should pick who's going next. So I don't know if I was going to, Don, do you know if Sam will be available next week?
I'm not sure.
Well, we can.
Is it my turn again?
Is it what?
My turn?
Yeah, it was your turn like 10 minutes ago when I said
Sorry,
an opinion.
Forrest, is it weekly or bi-weekly?
It's
Said
fine.
it was your turn 10
Okay,
turns
cool.
ago.
What week did
I don't know. Maybe he means you have to present all the time.
Oh, is that what you mean? That I should present all the time?
No, when I said, hey, Diego must have an opinion 10 minutes ago, and you didn't say anything. And I just, yeah.
Oh, that's why I hear him weird. Okay. All right.
All right.
So we have volunteers.
So do you have an opinion, or you want to go for the presentation?
Do you have an opinion about the modules versus superclass versus subclass?
Well, you know, I use a template like a module as template a lot.
Mm-hmm.
Like if you look at some of my code, in the stats and that kind of stuff. But the interesting thing for me in the chapter was to view modules as roles, like like I don't see them. I don't always view module as roles. Sometimes I see like this is like a common functionality, but not as a specific roles.
Mm-hmm.
And while Sandy is much more methodical. So that's kind of like my take on the chapter, if you want. It's like how, like I like the book because she's extremely methodical about everything. And she's like, okay, if we envision roles and how we can share code on roles, modules that make sense, and blah, blah, blah. But like sometimes I have cases of roles, but I do not implement it as modules, which maybe like if I were to say, okay, when I see this kind of need, this is the tool. It's like, yeah, that's probably right.
No, I mean, I think modules give you I guess two things. If you just want to organize stuff, but you don't want to have this one class that's 9 million lines long, you can pull it in a module. And if you're kind of organized, they're kind of themed modules. Like I call it logging, right? If no one else uses those modules, maybe it's a role, maybe it's not. Clearly, if other people use the object and this shared behavior and it's well organized, is likely to be a role. But sometimes you can just organize your code with modules. That's kind of handy. And Diego remembers DCI. They tried to implement DCI as modules, and you could do it except that it had. I don't know if this is true for the modern Rubies. For the old Rubies, it's pretty expensive as far as speeding up, lookup, or not speeding up, slowing down lookup time. But the idea of, and if you think about DCI, that's, in retrospect, that's all about roles.
Yeah.
It's all about using modules as roles.
There is...
The context is the role. So so you pretty much in DCI, you say in this context or in this role, this piece of data has this type of interaction.
Yep.
I think there's some differences, but it's fairly close.
One of the concepts in Ruby that was not covered in this chapter that I've seen in code here, that I still don't quite get, are the delegate keyword. You see it in class, and it delegates to this and it delegates to that.
I don't like this.
And modules, it appears that if you've got a method on the module, then the concrete class that uses that module, you get it for the callers get to that module's method free. You don't have any delegate statement at all.
Yeah.
So what I'm confused about is, what is the delegate keyword used for?
Oh, she just means that in a generic sense, because you don't do any work.
No, in Ruby.
Well, there's two ways. Delegate is literally, it's a, it lets you do, I forgot the name of the pattern. It lets you say, hey, this thing.
Rename.
It's not the, it's like the alias method, or
like
method change. Yeah, there is something in the standard library. There's a pattern, I forgot. It might be the delegate pattern. Well, I'll start with basic principles. I got a dude, an object, and I have another object. And if I delegate all requests, I don't know, log. This guy calls log, and he turns around and calls this log guy to do it. So I'm delegating to him. Ruby gives you two ways to very easily say, hey, I have a subchild. Take all my calls from here and send it to that guy in one line. Now, of course, you can just do that by hand. Def delegate, logger.log, my stuff. So you can do it by hand. Ruby gives you in the standard log two different ways. I think one of them is forwardable or something. I can't remember off the top of my head. But basically, you're delegating. So when she says delegate here, she's mostly meaning delegate.
Right. Because
you do nothing. When you include the module, you don't do any delegation. Mm-hmm. But you need to know, back to the careful part, you need to know where in the hierarchy it's getting called. Because that will show you the precedent. If multiple things redefine that method, how you defined it matters which one gets called. That's back to the careful. Right. Ideally, if you're not, but there's no delegate, you don't do anything. All you do is include something, automatically happens. that being said, there's at least 2 ways in the standard library. I forgot design panel. I want to say delegate because it's called delegate. Affordable, I think, and delegate are two things that come with.
Delegate's part of active support.
So yeah, there's stuff built into Ruby, at least 2 ways. Offhand, I don't remember what those are.
Be interesting to question comes up to me is when would you use modules and when would you use delegate?
Well,
It seems like
delegate requires you to have another object to delegate to.
so it comes more along in composition.
Yes.
Okay.
It simplifies your composition.
Okay.
Right, but to use the word mixing, the module just lets you mix these methods into your thing.
Right.
Which again,
Pros and cons.
from C++, it doesn't have anything at all.
Mm-hmm.
Yeah. Is David going to say something?
In the case with modules, the way that we're talking about roles, bicycle, vehicle, mechanics, none of those should have a role scheduled as part of the main roles. And so these modules to say, hey, now these objects can respond to schedulable and scheduled.
Right.
So now it's like they're learning the new skill or new set of methods. This is an okay interpretation of how we should think of modules, kind of like, oh, our object now knows something that other objects know, but it's it as an object.
Right. It kind of is, yes. Like generally modules is like different type of object that have similar behavior, right?
The learning knowing thing is an interesting way to look at it because I can see that, but I wouldn't do it that way.
You can get a ride on a car, on a cab, is a different thing, but they're both a ride.
Yeah.
The friend is not charging you. The cab is charging you.
I would go back in, the point of this was, again, roles are these, how the objects interact. You realize, oh, these objects have this role. It has more to do with organization and behavior. It just happens the implementation we can have in Ruby is via modules. So I would separate how it's done versus why we are doing it.
Mm-hmm.
Right, and so when you say learning about this, it's probably good not to conflate them together. You don't have to. You could just delegate. You can make a schedulable object and then force each guy to have it. And then to use that thing, then you can use the Ruby keyword to delegate that object in one line. Mm-hmm. So deal like that. So how you do it is different than what or why you're doing stuff. And if we're doing this in Java, we don't have that option at all. We either have an abstract class, but if we wanted to, actually, but that only works if you're in the main hierarchy. So in Java, you'd implement an interface, and the compiler will force you to implement the methods. So you get that checking, and unfortunately, you have to cut and paste. And maybe if you get tired of cut and paste, you have an interface, and then you'll use delegation via composition to implement that, so we don't have to cut and paste stuff. So it gets a little more painful in Java, but again, there's the why these things all act like this versus how you can do it, which modules just give you two things. They give you a namespace or a method, or methods you can mix in, or both. That's what they do. That's how they act. All right, anything else?
You guys need a better mic.
Oh. Take it up with my MacBook. I'm just got the one using it. Tell Apple to make laptops that are good now.
I'm actually looking up a USB microphone for you.
Okay.
All right.
Well, I was better when I had the headphone, but then Scott can't hear. All right. If we're done, then I don't know. Diego, is Diego volunteering for Chapter 8 then?
Yeah.
Okay, Diego does Chapter 8. We'll see you guys in 2 weeks.
Thank you.
Thank you for
Nice to
joining.
meet you all.
Yeah, nice to meet you, Matt. Nice to meet you again. Almost meet you. Nice to see your picture.
Yeah.
There you go. All righty. See you in 2 weeks. YouTube should be up there instantaneously. Post if you want to go back. Oh, and actually, Matthew, you can go back to old YouTube. Everyone but session 2 was recorded, so I'll put up the slides.
Ah, okay, nice. I can go have a look at those then, and then I'll read the chapter before the next meetup.
And I'll attach Scott's slides to the YouTube thing. Actually, we'll have a web page for this series at some point. So, okay, thank you.
Really appreciate it. Thank you.
Yep. Bye.
Bye.
Bye.